okay, find the nth term for each of the following sequences. So let's look at the first one here, 5, 9, 13, 17, 21. And you know, by the way, this type of question always comes up, right? It's a standard type of question that comes up at GCSE. So this is really worthwhile understanding it and remembering that sort of an approach so that we can be successful at it. Now, when you see a sequence like that, you need to see what sort of pattern is there, okay? And in this case, can you see here that we're just, quite simply, it's adding on 4 each time, isn't it? Okay, so to get to the next term, you've always got to add on 4, okay? So it's increasing by 4. And when you have that, okay, what I suggest you do then underneath is to write the 4 times table, okay? So because it's increasing by 4, write down the 4 times table. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. And that's the 4 times table, okay? And when you compare it to the actual sequence, okay, something sort of remarkable sort of occurs here in that actually this here is 1 less than the sequence, yeah? So if you think about it, all I've got to do is I've got to take the 4 times table and add 1 onto it, and I get my sequence. So if I add 1 onto 4, I get 5. If I add 1 onto 8, I get 9. If I add 1 onto 12, I get 13, and so on, okay? So just got to add 1 onto the 4 times table. Now what's good is, and this is where the nth term idea comes in, is the 4 times table can be represented by this algebraic expression here, 4n, okay? That's what represents the 4 times table, because what you're effectively doing here is you timesing 4 by a number, okay? That's what 4n means, 4 times n. So you see 4 times table. And as part of our result then, we're going to have 4n, but you just got to ask yourself then, okay, well, what did I do to my 4 times table to get to my sequence? Of course, we have to add on 1. So my nth term, my result, will be 4n plus 1, okay? And that's it, okay? Now, there's also a shortcut way you can find the answer as well, okay? And that is just remembering, because the gap is 4, you write 4n, okay? Whatever the gap is, you put it next to n. And then what you can do, just imagine there's a term before it, okay? Now there isn't a term before it, but if there was, what would that be? Think about it. Because it's going up in 4s, what would the term before it be? So if we go back 4 from 5, we'd end up with 1, wouldn't we? And that's what we have here, okay? And that will always work, so it's worth checking that. So with the next one, if you notice here, let's look at this one, this is going up by 6s, yeah? So we're adding on 6 each time. You get the idea, right? I don't have to do it all. So 6s. So what I'm going to do then is I'm going to write the 6 times table out. So 1 times 6, 2 times 6, 3 times 6, 4 times 6, and so on, right? 5 times 6. Okay, now the 6 times table is just represented by, can you think about what the algebraic expression would be? Well, of course it'll be 6n, yeah? Because it's just 6 times a number. You know, that's 6 times the number 1, that's 6 times the number 2, that's 6 times the number 3, and so on. So this is 6n. Now look at this and ask yourself, what could I do to this to get to my sequence? If you look at 6, for instance, to get to 9, think about what I need to add on in this case. I need to add on 3, yeah? And it works. If I add on 3 here, add on 3 here, add on 3, I get it. So my nth term is going to be 6n add on 3, okay? Now let's see if that little trick worked from earlier as well, okay? So because we're adding on 6, it's 6n, and then if you just imagine, like an imaginary term there, what would that be? Is it going to be that? And if you think about it, because it's going up in 6s, that is going to be 3 there. So if you go back 6, you'll end up with 3, okay? Right, let's look at a couple more. Okay, so we've got 3, 10, 17, 24, 31 here. So in this case, if you notice, it's going up in 7s. So if I write the 7 times table down, okay, that would be represented algebraically by 7n, of course, yeah? 7 times a number. Okay, so it's part of my answer. It's going to be 7n. And we need to think then, what am I doing to 7 to get to 3? What am I doing to 14 to get to 10? And in this case, it's going down, isn't it? So I've got to take away. I've got to take away what? Well, to get from 7 to 3, I've got to take away 4. Okay, so my nth term is going to be 7n minus 4. And I can always check then the quick way, is that going to make sense there? Am I going to get that? Well, if I imagine there's a term in front, all I've got to do, because this is going up in 7s, I've just got to go back 7. And if I take 7 from 3, I do indeed get minus 4. Okay? Right, let's look at this one. 8, 16, 24, 32, 40. Well, if you look here, it's going up in 8s. We're adding on 8 each time. So that means I'm going to write the 8 times table down. So 1 times 8, 2 times 8, 3 times 8, 4 times 8, 5 times 8, and so on. 40 there, isn't it? Now, notice here, of course, that's my 8 times table, which would be 8n. But it's just the same as the sequence, isn't it? Okay? It's just the same. So you've got to ask myself, what do I need to do to this to get to the sequence? Well, I don't need to do anything. In fact, I just need to add on nothing. So 8n plus 0, I can say, right? Which of course will be 8n. Okay, I don't need to put the plus 0 there. And again, going back to our little trick, does it work? Well, just work out what that imaginary term would be. If I go back, I could go back 8, I'll end up with 0. So it makes sense, doesn't it? Okay, now that sort of imaginary trick way is going to help us with this last one, right? Because with the last one, if you notice, it's going down. Okay, it's going down by 4. You've got to take away 4 each time. Okay, now what that would mean is then, because it's minus 4, you need to sort of like write down the minus 4 times table. Now I'm not going to go into that, okay? What I'm going to do is, because I know it's going down minus 4, I'm going to write minus 4n here, okay? So if I had wrote down the minus 4 times table, I'd be writing down minus 4n to represent it. But then I just got to work out what am I adding on at the end. And again, you just got to go back and think, what is this imaginary term here? Okay, if I go back there, well, think about it. I'm taking away 4. So if I go the other way, think about it, because if you go this way, they're getting bigger. So I'm going to have to add on 4, and I get 29. Minus 4n plus 29 is my nth term in this case.